If you're looking to run precise health check on your Kubernetes workload, then this episode is for you. Welcome to Is It Observable? The main objective of Is It Observable is to provide tutorials on how to observe a given technology. Today's episode is part of the Kubernetes series where we already covered several episodes. How to collect metrics out of your cluster, how to collect logs using various solutions like Loki, FluentD, FluentBit, Stanza, what is a service mesh, the power of Kubernetes events, how to auto-scale your Kubernetes workload, and more. Today's episode will be focused on a CNCF project that allows us to run precise health check on our Kubernetes workload. And I'm referring to Kuberhealthy. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what we are going to learn out of this episode. We will start with an introduction explaining the notion of synthetic monitoring. We will then explain what is Kuberhealthy, and you will see Kuberhealthy comes with a couple of components and CRDs, so we will look at the various CRDs that Kuberhealthy is adding in our cluster. We will look at the predefined checks provided by Kuberhealthy. We will look at how to create your own custom checks, and then we will see the ability to report metrics from our synthetic checks. And of course, as usual, we will jump into a tutorial. To guarantee that our environment is running smoothly, and we enable several types of things. Of course, as a start, we need to have observability. So collect metrics, logs, traces, profiling, and so on in our environments.
Of course!
Then we will build a set of alerts, usually based on fixed thresholds. The purpose is to be alerted if our resources are running low. The objective is to set the right thresholds to have enough time to recover. This is where we can implement auto remediations, where we create a specific process for a given alert. This process will recover from based on the alerts. So it will avoid crashing our systems during production hours. But auto remediations, even if we apply it, we are still required to analyze the current situation and the problem to avoid this issue to be repeated on and on in the future. In fact, when we do auto remediation, we usually apply a quick fix or like a quick tape that we put on the problem to avoid the crash. The tape, of course, is not a suitable situation for long term. This is why we still need to analyze and avoid to have these problems being repeated on and on and on. Then we also can create processes that will continuously check that our system is really running. For example, if I want to make sure that I'm able to write in a given file or a folder, I could create a small process that will try to create a file in this folder every 10 minutes. If I'm facing an issue, I will be able to be alerted when this check is failing. This type of continuous check are designed to report lots of various validations. So technical validation, so we could, for example, control that our network is up, that the DNS is fully working, that we are able to deploy, that we're able to write or read on a given file. We can also apply functional validation. Usually this type of validation is named synthetic monitoring, where we'll trigger a process that will interact with our application and check that the response is produced as expected. There are several types of synthetic validation. So they have the pure ping that will only control that the system is listening. So it will try to establish a connection to that endpoint. If the connection has been established, then our test is successful. If we're facing to a problem with our type of check, so we are not able to establish a connection, we don't really know where the problem is located. Is it related to the ingress, to a service, to the DNS, to the actual pod? So there are lots of potential sources related to that issue. We also have the ability to create HTTP check, so we can create an HTTP request, we send traffic to a given endpoint. This is very close to a ping, but the difference is that we're going to validate that the response generated has the right output. We can select an HTTP endpoint that will check several critical components of our systems. So if we send an API and we know that behind that API we have several components involved, it will be a way of checking that all those components are up and running. Last, we can execute a user journey, testing a real functional use case. For example, I'm running a user that load the main page, search for a product, add it in the cart, and so on and so forth. This type of check is more precise because I'm interacting with the application and see if the various components required for the various pages that I'm going through are responding. Again, the user journey needs to be defined properly to test our front end, but also all the critical dependencies that our application rely on. Because we will run this process in production, we will probably need to create specific data sets for this script. So for example, like a login user, if we need to log our users in our script. All the synthetic tests needs to be executed on several locations to understand if our problem is global or only related to a specific region. We often combine a local synthetic test, so close to our server, without any major latency, and then we add at the same time, same tests, various locations. Synthetic tests are very important, and it usually needs to be combined with real user monitoring. Real user monitoring will collect user behavior from the browser or from the mobile native application, and we would be able to understand the experience that we deliver to our users. But not only, we're also able to see what are the areas where our application are currently used by our end users, and also we can measure the impact of an outage from our business perspective. So example, if we have an outage, if we know that we have a couple of orders that have been placed by our users, we can basically estimate the average cart price or order price that we are not able to take during that downtime. That is the reason why real user monitoring is very powerful, but it's not enough. You still need synthetic monitoring because it doesn't require at the end real user or real traffic to detect an issue. If our environment breaks in the middle of the night, synthetic monitoring will be the only way of detecting the issue before our users. All the continuous checks that we can create are mainly designed to detect issues at the end of the day before our users are able to discover them. Most of the observability vendors of the market has synthetic or real user monitoring included in their offering. In the Kubernetes world, we can trigger continuous validation, but it could be difficult to deploy and manage and maintain over time. In fact, if we step back and we look at Kubernetes, Kubernetes also has an options where we can add readiness probes. So they have some checks. So readiness probe in one end and health probes. The readiness probe is designed to run a test that will control if our application is really ready to take the traffic. The readiness probe will be used to update the running conditions of our pod. The health probe is designed to let Kubernetes run a regular check to control that our system is healthy. This is going to be used to identify which pod will serve the traffic from our Kubernetes services. Those probes can be designed in various ways. So first, we can send an HTTP request using the HTTP probe. We will need to expose a specific endpoint, and it will be used to send this HTTP GET request. The probe at the end will only look at the HTTP response code generated by our system. We can also trigger a command. So basically, we will run a command inside of our container to check that our app is running or the process is also healthy or whatever we want. Last, we can also send TCP connection. So Kubernetes will establish a TCP connection to a specific port. If the connection is established on our pod, we will consider that it's healthy. It's a bit similar to like a ping check. But those checks are usually designed for orchestration mechanisms of Kubernetes, and we are not able to export those checks results and use them to build alerts. That is the reason why we have specific solutions designed to trigger synthetic test. And that's the case of today's solutions, Kuberhealthy. Kuberhealthy is a Kubernetes operator, allowing us to run synthetic monitoring and continuous verification on our Kubernetes workload. The value of Kuberhealthy is to help us building custom checks against our Kubernetes workload. Of course, it also comes with predefined checks to check that the core Kubernetes components are running, that we are able to deploy, and so on. Kuberhealthy relies on Prometheus to expose extra metrics out of the various checks that we are running. Therefore, when deploying Kuberhealthy, we have several options. Option 1, we don't have Prometheus, so Kuberhealthy will deploy the operator plus Prometheus. Option 2, we have Prometheus, but we're not using the operator. So it will deploy Kuberhealthy and also create the right scrapping rules for our Prometheus instance. Last, we have Prometheus operator, so in that case, Kuberhealthy will be deployed, and we will add in top of that the service monitor or the pod monitors. Kuberhealthy can be deployed in various ways, using a traditional manifest file or using a Helm chart. When deploying Kuberhealthy, you will get the Kuberhealthy operator that will be deployed with the help of a deployment file, a Kuberhealthy service that will be designed to receive the various status of our checks and also expose the generated Prometheus metrics. We will have also out of Kuberhealthy a preset of checks that will be running. So we have the daemon set check, we have the deployment check, and the DNS status check. So we will talk about them later in this video. Last, we have a config map. The config map holds the configuration of Kuberhealthy. And also, when deploying Kuberhealthy, it will also add a couple of new CRDs, so custom resources definition files, so new objects. So we have the Kuberhealthy check, the Kuberhealthy job, and last, the Kuberhealthy state. Kuberhealthy comes with lots of predefined checks, but we have the options to create our own custom checks. When deploying a check in Kubernetes, it will follow the following process. So first, we define our check, either one single check that will run once, or a check that will run every X seconds. In fact, that's the difference between a Kuberhealthy check and a Kuberhealthy job. Job is designed to be executed only once. Once the check is deployed, the operator will deploy the pod that holds our check. Then the pod check will execute the various operations defined in our validation mechanism. Once it has ended, it will report a status by creating a Kuberhealthy state. Once the state is created, it will generate Prometheus metrics accessible from Kuberhealthy. Like explained, Kuberhealthy allows us to create checks with the help of the CRDs. We have the Kuberhealthy check, also named KH check. We all have the Kuberhealthy job, also named KH job. Kuberhealthy check is designed to create checks that will run continuously every X seconds. To define a KH check, you will need to define, of course, the metadata, so the name, the namespace holding this check, the specification of the check, so the run interval, so how frequent you want to run this check, the timeout, and then we can add extra annotation that will be included on the annotation of the pod created by Kuberhealthy. Extra labels to add labels that will be added to the pod created, And then we move to the pod spec that will hold the configuration of the pod that will be triggered. So we have containers. So of course in containers you will have environment variables, image policy, the name of the container, the request and limits, the volumes, and so on. As you can understand, the logic of your check needs to be held in a container. Kuberhealthy jobs. Like mentioned, KH job is a Kuberhealthy check, but that will be only executed once. That is the reason why the CRD of the job is pretty much similar to the Kuberhealthy check, except it doesn't have a run interval. To re-execute a KH job, you will need to delete your KH job and then reapply it. So here is an example of a Kubernetes healthy job. As you can see, we find a similar information that the Kuberhealthy check, except that we don't have any run interval property. Kuberhealthy will generate events. By looking at the events, we could understand if a given check is running into error. Otherwise, if you're looking to debug your checks that you have built, you simply need to look at the logs, the std out, of the pod check created by Kuberhealthy. Once your job or check has been triggered, Kuberhealthy state will be produced. Kuberhealthy provides a specific object that will hold the states of our job, our check, the Kuberhealthy states, or KH states. Kuberhealthy state will have errors, so a list of errors related to the check, the last execution time, the node where the last check has been executed, the status, so okay, it could be either true or false, and also the run duration. So the similar information could also be available when you also interact with the Kuberhealthy service on the port 80, and if you look at the Prometheus metrics, you will also have the similar informations. Kuberhealthy provides a list of predefined checks. So here is the URL to look at the various checks available. Let's have a look at few of those checks. So we have the daemon set that will be deployed by default with Kuberhealthy that will check if we are able to deploy and schedule a daemon set in our cluster. It will wait to get all the pods in a running state. You have also the options to pass an environment variables with the node selector to only deploy the check in a specific node. We have the deployment check that will do the similar type of checks but with deployment. So it will deploy a Kubernetes deployment, and you can also define environment variables precising the number of replica that you would like to deploy. This check at the end will send an HTTP GET request to the new pod deployed, and if it returns HTTP response code 200, then it will be successful. Pod restart, so it will check that there are no excessive restarts in a given namespace. You will need to define the max failure allowed to tolerate a number of restarts. You can also run this check on the entire cluster, and you will need to deploy the right service account with the right cluster role and cluster role binding. Pod status check. This will validate that the latest pods are not in an healthy state. If the pod is stuck in pending state, it will report to be unhealthy. By default, similar to the other, it will run on a specific namespace. So if you want to run it entirely on your cluster, make sure to apply the right RBAC. DNS status check. This check is going to look for DNS errors, including resolving internal network communication in the cluster or outside communication out of the cluster. The environment variable that will be used are the host names that will hold the address to check. The DNS pod selector and the namespace will be used to select the pod managing the Kubernetes DNS. HTTP request check. This check will send an HTTP request, so get, put, post, delete, whatever the methods, to a specific URL. It will check that we are able to receive an HTTP code equal to the one we expect. So that's why you need to define an environment variable called expected status code. So if you don't, by default, it will check that it generates a 200 HTTP response code. HTTP content check is similar to the previous check, but here it will also check that the generated response contains a specific string. Of course, there are more predefined checks like the resource quota. It will control that the resource quota defined in a namespace are under a given percentage. Network connections. So here it controls that we can send a TCP package to a given endpoint. The image pool will check that we are able to pull out an image for a given Docker registry. There is the storage check that controls that we're able to create first a PVC, then we are able to write into it. Of course, there are more checks, so if you want to look at the various checks, don't forget to look at the lists of checks provided by Kuberhealthy. Kuberhealthy also provides a library allowing us to create our own set of checks. To create our own checks, Kuberhealthy provides a client library in Go, JavaScript, and recently in Python. The client library is designed to report the status of our checks with the methods like report failures, where the lists of errors that we have encountered, or if we want to report a success, we use the report success methods. Technically, you don't need to use the client library to report your failures, because at the end, the client library is sending an HTTP post request to Kuberhealthy. So if you're using a language that doesn't have an existent library, you will simply need to send a post request to Kuberhealthy to report the success or the failure. So here is the payload that you need to send to Kuberhealthy. So OK report the success or the failures, so with true or false, and errors has the list of errors detected by our check. Of course, errors needs to be empty if the status is true. From the descriptions of the KH job or KH checks, Kuberhealthy check has a timeout. So we will also need to check that our task is ending before the timeout. For that, Kuberhealthy add automatically environment variables when they start our pods, holding a couple of extra information. So we have the KH check run deadline that holds, in fact, the Unix times of the deadline of our tasks, the KH reporting URL, so the address where we want to send our success or failures, KH pod namespace with the namespace of the check, KH run UID. So if you're using a language having no Kuberhealthy library, you will of course need to retrieve the KH reporting URL to send the right status of your check to the right Kuberhealthy instance. Also, don't forget to collect KH check run deadline to also control that you are running tasks before the actual timeout. The beauty of Kuberhealthy is that all the status of the checks that we've built or the jobs created will automatically report Prometheus metrics. The metrics will be available on the Kuberhealthy service, so the default port is 80 and the endpoint for Prometheus is /metrics. The generated metrics would be Kuberhealthy check duration seconds, so it's a gauge metrics for all our checks. That holds, in fact, the duration of the check. And then we have the Kuberhealthy check that will report the status of the various checks. Each Prometheus metrics will have specific labels. We will have the check name, so the name of our check, the job, the namespace where our check has been running, the status, so 1 is equal to success and 0 means error. And then we have an error label that will report the name of the error that we have detected. So at the end, we can easily utilize our check that we have deployed to create alerts in our observability solution of our choice. In these tutorials, we will use Kuberhealthy to run pre-deployed checks, so the daemon set 1 and the deployment. And then we will build our own custom checks using two distinct solutions. Locust, so it's an open source load testing solutions. The Locust requires a script built from a Python, and we will see how to build checks using the Python library. The second solution is Tracetest. So Tracetest is an open source solution running HTTP checks by controlling that our request has the right spans generated. So for this example, we will build a Go script utilizing the Go library to run a Tracetest file using the Tracetest CLI, and we will look at the various errors or success produced out of the test. For this tutorial, we will need, of course, a Kubernetes cluster, the Prometheus operator, the Open Telemetry operator that will require the cert manager, the nginx ingress controller to expose Tracetest out of the cluster. Of course, we will deploy Kuberhealthy, and for the example, we will also deploy Tracetest. And finally, to demo everything and measure the availability, we will use the Open Telemetry demo applications that will also produce traces on the background. All the traces and all the Prometheus metrics in this tutorial will be sent directly to Dynatrace. So at the end, we will look at the metrics produced that we have ingested into Dynatrace.
Like every tutorial that we delivered at Is It Observable, there is always a GitHub repository, and here we're looking at the repository related to Kuberhealthy, of course. So a couple of things. So you need a cluster. So here in my case, I'm using GCP, but if you want to use another flavor, you are free to do that. You just need a cluster. Maybe with, here I took 3 nodes, but 2 nodes should be enough for sure. The other thing is, in these tutorials, we will rely on Dynatrace because I will ingest the traces produced by the OpenTelemetry demo in Dynatrace, and also the metrics produced at the end with Prometheus will be sent into Dynatrace. So that's why there's this instruction with the Dynatrace. So if you don't have any Dynatrace tenant, there's a link here for a Dynatrace trial, and you will just have to fill in your email address and you get a free trial. A couple of things related to Dynatrace. The first thing is we need to have an access token. So in Dynatrace, once you have your tenant, you don't have to install an agent. We'll do an agentless approach. We will click on access token on the menu left. And here, you probably have less tokens than I have here. And then we'll create a new token. So access new token, we give a name. So I already have it done it. So I can say, let's say test, for example. And then I search for some scope. In our case, it's ingest. So we're going to search for ingest. And here you can see that we have traces, metrics, and it's going to be both are good enough. But logs, we are not ingesting them, so you can unselect that for sure. But at least metric and traces. So once you have that, you click on generate, and it will show you the value of your token. Save it because you will need it later for this tutorial. The other thing we need to save as well is the tenant URL. So in the top here, you can see I have my tenant URL. Select everything HTTPS until the .com. So you will have your Dynatrace environment that you will need because we will use it for the deployment script. So I didn't create all the instructions. I started to, since several episodes, I started to do a deployment script. So here there's a deployment script. You need to pass, like I said, the token, the tenant URL, and you can give a name, whatever you want. And that will deploy all the various stuff. So what do you expect out of this deployment? So let's check it out. First, you need, in terms of namespace. So if you look at the namespaces, for a couple of things. So first we'll have the cert manager that is required for the OpenTelemetry operator. You will have the OpenTelemetry operator namespace, and then you will have the ingress nginx for the ingress. You will have, of course, the hotel demo application, so namespace. We will use Tracetest later on, so we'll have a Tracetest namespace. And of course, we have the Kuberhealthy namespace as well. And in the default namespace, so let's check the pod. We'll see that we have, of course, the all the kube stack, the Prometheus kube stack component deployed, so the alert managers, the node exporter, kubeset metrics, and of course Prometheus and Grafana. And inside of that, you'll see that I have 3 collector instances. So this has been deployed with the operator. So I have 2 a collector for OpenTelemetry, one as a daemon set that you can see here, and the other one is injected as a sidecar within the hotel demo applications. So now let's have a look at the hotel demo applications. So the hotel demo application, we have all the various pods related to the hotel demo. Most of them has, you can see there's two containers, one with the sidecar collector and the other one with the app, except of Redis that doesn't have that. But this is what you're going to expect from the hotel demo applications. You can see that we have also an Ingest, but we won't use it, to be honest. This one, so this is the Ingest created. We'll have one also. If you look at Tracetest, we also have the Tracetest server plus the database. And if we look also, we have an ingress for Tracetest, which is here. Last, we have Kuberhealthy. So let's have a look at the Kuberhealthy, what we have. So let's have a first look at the pods running in the Kuberhealthy namespace. All right, so if you look at the Kuberhealthy namespace, we can see several things. We see first we have two instances for the Kuberhealthy server that receive failures or success, and also expose Prometheus Metrics. So we will have, of course, a service behind the scene. I will show you in a few minutes. And you can see that we have already some checks running. So daemon sets, deployment, and DNS. And those are the default one that comes with Kuberhealthy. So if you look at the service, we can see that we have the Kuberhealthy service, which is deployed. If you look at the KH check, which is the one deployed, you can see we have the three deployment, daemon set, deployment, and DNS currently running within this cluster. And last, maybe we can just check briefly. We can see if we KH state, we can see that the 3 check is reporting true. It's working fine. We see the last execution run. And so we have the details on when those checks has been executed for sure. All right, so the next step is about the Prometheus metrics. So because we already have checks running, we can look at the metrics exposed already on the Kuberhealthy service, because like I said, we have already some Kubernetes state and checks running. So we have metrics populated. So for this first, before we configure everything, let's have a look by doing a port forward. And here I will pick like 8085 locally on my laptop, and the port of the service is 8. All right, so now the port forward has been done. So if I do localhost, as you can see, we have already metrics produced. So we have the Kuberhealthy checks. So we can see that the status of the latest one, so 1 or 0. And we have various labels, so the name of the check, the namespace, and the status. And if there's errors, I will have also the details of the errors. We have the same thing with the check duration in seconds, how long it took to check. So if you do a basic check, so here you can see that it took 74 seconds to do the deployment check, 12 seconds for the daemon set, and 5 seconds for the DNS. So that's the typical type of data that we have. So now what I would like to do is to be able to send over those metrics to Dynatrace. So we have 2 collector pipelines running. One is in a sidecar. This is the sidecar one that basically just collect metrics and traces and push forward it back to the OpenTelemetry collector settings in the default namespace here. So here we know, obviously this is not the one that we'll touch, but we have a specific file here, OpenTelemetry_Prometheus. So we have the one manifest is the one currently running, and the one with Prometheus is the one that is using the Prometheus. So the only thing that I did here, and first I have added here a receiver, Prometheus. So here I'm configuring a static scrap config. So I named the job Kuberhealthy, Kubernetes Kuberhealthy. It will scrap every 5 seconds. And you can see that here I am precising that I want to scrap the Kuberhealthy service sitting in the Kuberhealthy namespace, and it's a service on the port 80 and the default port, and the default endpoint is /metrics, so I don't have to precise it. So out of that, the only thing that I need is to add in the metric pipeline that has been defined. to add this receiver. So if you scroll down to the metric pipeline, you can see that I have a metric. So I have actually I have 4 pipelines, one for Tracetest, we'll see it later on, one for metrics, one for span metrics. Span metrics is a technical one, so don't pay attention to this one. But here the metrics is basically I'm receiving OpenTelemetry and Prometheus, and I will push it to OpenTelemetry HTTP, which is in fact Dynatrace. All right, so let's apply this one, and that would allow us to get metrics back in Dynatrace. So here I'm just apply this in the default namespace, and that will be updating our current collector pipeline. So if I do, you'll see that those pods are the one from the collector perspective. And now they have been restarted, so they should also grab the data coming here. So we have a couple of metrics. So let's check the Kuberhealthy check, for example, or the duration, and look at Dynatrace. So if you want to see that in Dynatrace, we will have to go to metrics. Okay, let's search for this. As you can see now, this Kuberhealthy check duration seconds is currently available. So I can create a chart with that, and you can see that we have the various check name and service. So here I can say split by check, and I will be able to see the daemon sets, the DNS status, and the others. So they will come up in a few seconds to have all the ones. But you can see that the metrics are coming in directly here in Dynatrace. And now we're going to look at how to create the custom checks. So if you go to the Kuberhealthy GitHub repo, there's a check creation here that's show you how to create your custom checks. So here there's a couple of examples using the Go library, the JavaScript, and like I said, there's also the Python one available. So today I will illustrate mainly the usage of Go with Tracetest and Python with Locust. So in the repository that in this project, you can see that there is a repo called load generator, and this load generator repo has a Locust file. So in fact, I didn't reinvent the wheel. I just took the one that is provided by the OpenTelemetry demo. So it's the load test running against the OpenTelemetry demo. So that means that this will basically end in the hotel demo namespace. The other thing that I did, I have here importing the KH client. So you will have to, of course, do the right requirements to import the right library. And once it's been here, you can basically see at late in one state here, what I do here, I change slightly the script. I test the status code of a given request. So going through browsing products and others. And if the status code is different from the one I'm expect, I basically use the methods provided by the Python library to report failure. So here report failure, and I say just the /product is not working. And I do then the same logic for the other requests. So same thing if the response code is different for the recommendation, I post a recommendation failure. Same thing for the data /data /cart, and also adding product and so on. So everything is here. And the thing that I've added is that if everything goes well in that user journey, I want to report at the end a success. So if on stop, if I was not been rejected or stopped by a failure, then at the end, once the iteration ends, I'll report a success. So that's the one. So this is basically the script using the Python. So out of that, I have a specific Docker instance here to first get the KH client in this Docker image, in the Docker container, and then I install and I build this application, and then the entry point will be Locust. Inside of that, I have a specific Kuberhealthy check. So you can see that I have a Kuberhealthy object here. I give a name for this check. I can add some extra labels if I want, or extra annotations. And then we have this pod spec where we have our actual container. So here the container is referring to the URL of our OpenTelemetry demo service, front-end service, and then at the end I didn't add any extra variables. I just removed, by the way, the OpenTelemetry instrumentation. So there is basically the vanilla version of the hotel demo load generator. And at the end here, you can see that I'm referring to this a container that has been built for this tutorial. So we could basically apply this. So let's have a look. All right, so the check has been created, and then if you want to check the output of your checks, you just need to look at the logs. So let's check the pods running there, and I should have in a few seconds the pod related to the check, because I said that it's going to run every 2 minutes or so. Here it is. We have the check creating, so we can take that pod name and start looking at the logs if I want to debug, for example. As you can see that we have one user. Here it is. It's been terminated, so now I should have the status reported. And then there's a new one creating. So if I look at the cage state, you can see that it's failed. So we can have the details on what was wrong in that state. So let's look at the metrics that we collected. So we should have it in a few seconds. Okay, now we have this. And now we have the error. So now we have the error, and I can look at the type of errors that we have. So here we see that we have a timeout. So we had a first error, say that we have the recommendation that is not responding, and then we have a timeout to report the metrics. So it took more longer than expected to execute it. So you can see that you can do the split, and so then you can count, do some various reporting about the errors. If you want to learn more, check out the episode on Tracetest. So here in this repository, I have a Tracetest server running. And we can see that we have no test. One important thing is the setting. So it should be configured already. So you can see that it's configured to OpenTelemetry. I already have included the right Tracetest configuration on my pipeline. So let me show you briefly. So that allows me to configure Tracetest to receive traces. So if you want to see that, you have to go to the one that we've just applied, and there is a specific instance for Tracetest here where I'm pushing the traces as well, and it's using a specific sampling tail sampling to only get the traces having Tracetest inside of that. So for this, two things. So you need first to create a test file. This would be, so here I have two things that I'm using with the Tracetest. Is one, the data store. So it's a way of creating a data store that will use the collector pipeline, even if it's a default one. And the second one is the HTTP check. So here I'm interacting with this application sitting in the hotel demo. So it's going to send this HTTP request. And then I'm doing some spans, check that I have some enough spans. It's a more advanced HTTP request because here we're controlling as well what we expect in terms of traces. So how do we create this? So I created a small Go program which is generic, so you can use it. Again, it could be improved a lot. I'm just checking that the output is not having errors. So here I'm just checking, what is it? Run trace test is basically I'm running a file, and I'm checking at the end if there is no errors in the output of the command line. So it means in this specific case, you can reuse it if you want and improve it, because it's of course very basic at the moment, but we can do way more things. So what I do to have this image, I build the container and I include the Tracetest CLI, because I will run the test through the Tracetest CLI. So that's very simple. And then, as you know, you can see I have two files involved. So that's why in my Tracetest check that I'm producing, I need to attach a volume. So you can see as the container environments, I only have the URL to the Tracetest server to configure my command line. And then I'm mounting a volume /test where I have expect two files, the test.yaml, and the other one is the data store, I think. And you can see that this test of folder is volume mounted through a config map. So that's why I need to deploy first a config map holding my two test settings, so my test file in one end and the data store on the other end. So that's how basically I'm able to interact it. So let's create this. So this is going to be a bit more advanced because we have the config map involved, but at the end it's going to be quite similar. So let's first apply. So here we can do this in whatever namespace. There's no preferences, but we can apply that in the Tracetest namespace, for example. So here I'm going to apply. So here it is, config map created. And last, we are going to deploy the check. So now this check has been created. So similar to the previous one, if I want to see where we are, I can look at the pods. At the moment, the check is not been set yet deployed by the operator, but I can do a watch. Here we have the check running, so we can see that first it shows you the definition file that it's using. So it's using the one check with success and configure with success. So it seems that it's almost, here it is. You can see that we have an output. We were able to get the right traces. So trend trace test with success. So now if I look at the cage test, you can see that we have a success run that took 20 seconds. So that means that it's running. It's not going to run every 2 minutes, which means now if I go back to Dynatrace, oh, here it is. We have our Tracetest check. As you can see, it's currently the one that is always failing is the load emitter, and Tracetest is fine. So now I can also get that details, and if I want it, I can say look at by errors as well. But there is actually no errors except on the one with the recommendation service from the Locust server for Locust check. But if I check the check duration, I will be able to split and see that, for example, the check that we use for Tracetest, where is it? Tracetest check is the yellow one. It's taking about 30 seconds.
That's it for today's episode dedicated to Kuberhealthy. Kuberhealthy is a very powerful solution that helps us to design checks that we can run continuously on our cluster. I really like the fact that there are predefined checks available and that you can also build custom checks. The only downside of that is that you need to build an image to build your Docker container. So there is no actual way of building easily like some bash command line or some TypeScript examples to run those checks. But again, this could be improved by opening a GitHub issue in the Kuberhealthy GitHub repository. The other thing that I would like to have in top of Kuberhealthy is the options to measure the response times. So if I'm sending a TCP connections or a TCP packet, or if I'm sending an HTTP request, I will be also interested to measure the time it took to do that. Specifically, when you run static tests involving several transactions, like we did with Locust, I will be interested to report the response times of the check product, the cart, and so on and so forth. So then I will have more indicators on what was wrong, what was successful within my test. All right, so if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode.